Students, in this session, we are going to learn about combination of cells in parallel. So, this is A and C are the two terminals. Here, the B1 and B2 are the two terminals here. So, the two cells are connected in parallel. So, EMF of the first cell is E1 and the second cell is E2. And the first cell internal resistance is R1. Here is R2. But current is not same. But in series, the current is same. Here, the parallel voltage is same. So, current I is coming here, splitted into I1 and I2, goes to the first cell and second cell, and it will be again, it will recombine here. I is equal to I1 plus I2. So the potential difference between the terminals of the first cell is VB1 minus VB2. First cell alone we can take that. That is V is equal to E minus IR. So already I told that you have to remember only V is equal to V plus V prime. That is E minus V prime, which is equal to V. Then E which is equal E minus internal resistance, internal voltage is IR, which is equal to V. So we are using this derivation only for calculating the series combination as well as the parallel combination. So V is equal to E minus IR, E minus IR. For the EMF of the first cell is E1 and the current passing through the first cell is I1 and internal resistance is R1. So we can write I1, which is equal to, you bring this term this side, that is E minus V by R1. So I1 can be written as, we can rewrite this equation as I1 is equal to E1 minus V by R1. Similarly, for the second cell, the potential difference is E2, second cell EMF minus I2 R2, then I2 which is equal to E2 minus V by R2. Why we are writing the V is a common? Because this is a parallel combination. The external voltage across these two cells are same. So then only we are putting that V. So that is here. Okay, so what the next point? So I1 calculated, I2 calculated. In parallel combination, we have to add I is equal to, total current is equal to I1 plus I2. So E minus V by R1 plus E2 minus V by R2. So E by R1 minus V by R1. E by R1 minus V by R1 plus E by R2 minus V by R2. So minus V by R2. So we can rewrite as E1 by R1 plus E2 by R2 minus V is commonly taken outside, 1 by R1 plus 1 by R2. That's all. The derivation is over. The current we are calculated E1 by R1 plus E2 by R2, then V minus 1 by R1 plus 1 by R2. That is, we can write as a simply E equivalent by R equivalent, which is equal to E1 by R1 plus E2 by R2. Then 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2. That's all. The derivation is over. But we can rewrite this equation in a some other form. That is, bring this I here and V into the left side. So we are rearrange that. Then what we are doing, that LCM or R1 plus R2 by R1 R2. Here the E1 R2 plus E2 R1 by R1 R2. So we are taking the LCM within this bracket and bring this voltage left side and current in the right side. We get the E equivalent, which is equal to this paragraph. This bracket R1 plus R2 by R1 will come to the denominator. R1 R2 get cancelled. Finally, we get an equation V equivalent, which is equal to E1 R2 plus E2 R1 by R1 plus R2 minus I1 into R1 R2 by R1 plus R2. So this can be written as like this. V equivalent, which is equal to E equivalent minus I R equivalent. V equivalent, which is equal to V equivalent, which is equal to E equivalent. This is a E equivalent minus I into R equivalent. So listen, students. Here the E equivalent, which is equal to this entire paragraph. Then R equivalent, which is equal to this paragraph R1 R2 by R1 plus R2. So we can represent this way or this way. Both are correct only. This is in terms of current. This is in terms of voltage. So this is the derivation for cells connected in internal resistance of the cells connected in parallel. So very simple derivation. Then the very important thing is, for the NEET and JEE questions, they may ask that what is the condition for maximum current in the series combination and parallel combination. So very simple, students. In series combination, total EMF, which is equal to NE. There is a n number of cells are connected. All the cells are equal EMF. So if it is a 5 cells are connected, 5 E plus E plus E plus E. So 5E. So if it is a n cells are connected, NE. Then the external resistance and internal resistance are connected in series only. So R is equal to NR. So very simple, students. NE represents the total EMF in series combination. NR represents the total internal resistance in series combination. So this R plus NR is a total resistance in series combination. So if R is very greater than NR, if you assume that the external resistance is greater than the internal total internal resistance of the cells, then what we will get? This NR will be neglected. We get only N into E by R only. E by R only. E by R is a resistance. E by R is a current for the single cell. E by R is a current for the single cell. So what is in this condition? The N times the single cell current. We get in this total combination the current will be maximum when the resistance are higher. If the resistance are lower in series combinations, we get the total current as a one single cell current. Again, I will recall you. If you take the external resistance is lower than the internal combination resistance, the total current will be equal to single cell current. But if the R is greater than the total internal resistance of all the cells, then the current will become maximum. So that is the condition. In series combination, the condition is external resistance must be greater. Listen students, this is a external resistor. Here this is the internal resistance of the cell. If you connect all the cells in series, that is the condition we are seeing in the previous case. Similarly, in parallel combination, we know that if all the cells are connected in parallel, the EMF, that is the voltage is same. So we get only E, that is R plus R by M. What is R by M? Is the internal resistance. Internal resistance of the cells. All the cells are connected in parallel. What we have to write that 1 by R plus 1 by R plus 1 by R. M number of the cells are there. So M by R we will get. So 1 by R which is equal to M by R. So if you take the reciprocal, we get the internal resistance of the cells connected in parallel combination is R by M. So if you take the LCM, we get here the M will come. So finally we get what is that? M into here M into MR, then M will come to the numerator. So very simple students, if the external resistance is very less than the internal combination of resistance, we get the maximum current. So very simple students, this is a one more question only for you. So condition for the maximum current in series combination means the external resistor will be higher value than that of the internal resistor, means we have to connect only series combination. If the external resistance is less than the internal resistance of the cells, we have to connect in parallel combination, or in other words, in series combination. If we want the maximum current condition, we should connect the higher external resistance to the circuit. Then only the current will be maximum. In parallel combination, if we want the maximum current output, the external resistance value must be less than the internal combination resistance total resistance value. Then only the current will be maximum. Are you clear students? Yes. I will show the pages slowly for writing in classwork note.